Okay, so on the second page, let's move on to question number 8, where we've got a 2,000 kilogram railroad car. It rolls to the right with a speed of 5 meters per second. The car collides with another car of mass 1,000 kilogram initially at rest. The cars collide and couple together. What is the speed of the coupled cars after the collision? Well, coupling means that they're sticking together, that they are basically one object. So when we do our conservation of momentum equation, object A and its velocity initially, and then object B and its velocity initially. Okay, so when we do this, there we've got that equation. What's going to happen is, since they're stuck together, object A and B are going to have the same final velocity, so we can get rid of that and actually combine them together. Okay, so what I did here was, this term completely cancels out, it goes to 0, and so I got rid of it. It's no longer over here. And then on this side, I took object A and object B, and I put them together inside parentheses and factored out the final velocity, since object A and B are stuck together and they're going to have the same final velocity. Alright, and so that's going to help me figure out this final velocity, because then my last step here is just simply to divide out the sum of objects A and B, cancel that out, and move that over here. Okay, so to find the final velocity, then all I need to do is take, at the very beginning, the mass of object A times its initial velocity, and then multiply that by the mass of the two cards total mass of the two cards once they're stuck together, the total mass of the system. So let's go ahead and start plugging in some numbers here. We have object A being 2,000 kilograms times its velocity, which was 5 meters per second. And then let's do the sum of the two objects, 2,000 plus the second railroad car, which is 1,000. Now be careful here, don't cross out the 2,000s. They don't cancel out because of this addition sign down here on the bottom. We have to add them together before we could do any kind of canceling. So be careful there. It's a common mistake, common algebra mistake. And you're like, danger, Will Robinson, bad algebra. You know, not good. So be careful with that. That happens. All right, so 10,000, 2,000 times 5 is 10,000. 2,000 plus 1,000 is 3,000. Okay. And so when we do the math on that, that'll leave us with 3 1/3, or 3.33333333 repeating. And that would be in meters per second. So there's our answer to question number 8. Now let's move on to question number 9. Question number 9, again, we're going to be using conservation of momentum. A person of mass 50 kilogram runs at 4 meters per second toward a stationary 5 kilogram sled. The person jumps and lands on the sled. What is the speed of the person? So you got just this little person running, and there's this sled over here, and he's running towards it, jumps on that sled, and then after, we are going to see, oops, the A didn't take, so after, we're going to see the person, and they have thus landed on the sled. So here they are, with their knees down, stuff bent, okay. You know, it's not the best picture, but whatever. Alright, so they're stuck together afterwards. Okay, so what's that going to look like in terms of an equation? Well, obviously the sled is at rest, so we only have one object running, and that's the person, and the velocity of that person before. So I'm going to kind of skip a step here. And the step that I'm skipping is, I know that there's only one object before, so I'm not going to put in the VB initial there, because I know that it's not there at 0. Alright, so then also at the end they're stuck together, and I know that these things are canceled out. We don't have to worry about object A's velocity and object B's velocity, because there's just one object afterwards, the person and the sled. So I can combine those terms, I can start combining stuff together there. Okay, and so hopefully you notice that we're really just kind of using a very similar equation that we used in the question before, where we're just finding the final velocity of the objects after the collision occurs, and we get this equation here. So we'll say the final velocity would be equal to ma, the mass object A times its initial velocity. So here it is, it's just that same final velocity equation from the problem before, and I just plugged in our numbers. The mass of the person running was 50 kilograms, running at 4 meters per second. The mass of that person was 50 again, the sled was 5, so 50 times 4 is 200 over 55. 200 divided by 55 is 3.64 meters per second on that problem. All right, so then that takes us to problem number 10 here. And it says, a sled slides on a frozen pond with a speed of 6 meters per second. A 3 kilogram object is then dropped onto the sled, followed by a 5 kilogram object. After this, the sled moves with a speed of 2 meters per second. What is the mass of the sled? Okay, so to figure out the mass of that sled, we'll use that same equation we've been using, but the only thing that was moving before in this problem was simply the sled. So I'm just going to say that the mass of the sled times its velocity is going to be equal to the mass of the sled times its velocity afterwards, plus, because we have that sled moving, plus, now we're going to have two more objects moving. So let's say we have the mass of object A times its velocity afterwards. Okay. And then we have another object dropped on it, B times its velocity afterwards. All right, so here we've got the beginnings of our equation. Now, we don't need to really worry about separating out these different velocities, because since they're all stuck together, we're just going to have one velocity for this sled. So it really is going to look more like this. Okay, with those final velocities. All right, now, since we're looking at the mass of the sled, let's try and get the mass of the sled on one side. So I'm going to subtract it out over here, okay, and put it over on this side here. So the mass of the sled times its initial velocity minus the mass of the sled times its final velocity, and that's going to be equal to the mass of object A times the final velocity plus the mass of object B times its times the final velocity. All right, so now I need to factor out the mass of the sled. So that's going to leave me with the initial velocity of sled minus the final velocity. And then we have the other components here. All right, and now let's divide out that velocity of those velocities right there from this side and move it over here to this side. Oops, sorry. Okay, so that leads us to this equation at the bottom. So all we need to do is then plug in some numbers. So the mass of that first object that was dropped down, so here's our object A, and then here's object B. So here's A, here's B. Okay, so the mass of A was 3, and the final velocity is given to us right here. It would be 2, so 3 times 2 plus 5 times 2 over 6, which is the velocity, the initial velocity of the sled, minus the final velocity of the sled, 2. Alright, so let's do some multiplication. 3 times 2 is 6. 5 times 2 is 10. 6 minus 2 is 4. So that's going to be 16 over 4, which is 4 in its mass. So 4 kilograms is the mass of that sled. Now, in part B, it asks if they were dropped in reverse order, would the final velocity of the sled be different? And the answer is no, it would not. It would be exactly the same. And that's because this initial equation up here, this equation would be identical there. The only thing that would end up flip-flopping would be we would have these two things being added in different places. But since it's addition, it's going to give us the same answer. So no, the final speed of that sled would not change. And that's actually kind of a question that they'll ask in a multiple choice format. And they'll say, if it's dropped in reverse order, what would be the new velocity of the sled? And then they would, or the new final velocity of the sled. And we'd have to look back here at 2 and say, oh, it's still going to be 2. And they might give you answer A, it's going to be 1 meter per second. Answer B, it's going to be 2 meters per second. Please choose B. Answer C, it's now going to be 4 meters per second. Answer D, 6 meters per second. Answer E, 8 meters per second. So, you know, you'd have to go in there and choose the correct answer, and it would be the same right there. So if they give it to you in terms of multiple choice format, that's what they do. And we've seen that before on the AP exam.